I'm David Wilson, and I'm from the University of Bath. Okay, so I work on the geometry behind computing. So I'm looking at underlying algorithms. What's the geometry, and how can we use that geometry to analyze those algorithms? So there's ways of verifying software by translating into mathematical statements, and I look at how we can analyze those mathematical statements. And it's through a process called cylindrical algebraic decomposition, which was invented back in 1975. And it decomposes n-dimensional space according to sets of polynomials, sets of mathematical equations. But the problem is that it's really inefficient, and it produces thousands of these cells, which are its output, whenever you try and tackle a problem. So I've kind of torn apart this algorithm and looked at all the different sections of it, seeing where we can improve it and how that all interacts when we put it back together. And kind of the problem is that putting it back together isn't straightforward, and that sometimes less can be more. And we have examples where only applying a couple of the advances is actually better than applying them all at once. So this has been my work. I've been working on it for the last 3 years. So I've been working with the team at Bath, and we've been working with some researchers all across the world to try and improve the efficiency, because this was becoming a real bottleneck in these computations. We were finding that people could create these expressions describing these software, but we couldn't actually solve them quick enough, or you would set it off and it would take 3 days to run this algorithm. So that's kind of the motivation behind all our work, is just to try and make it more efficient and more useful. So we've got these different improvements so far. We've got ideas to extend them all. One thing that I'm really excited about is we've been working with a team at the University of Cambridge, and we've been applying machine learning to this. So we've been looking at how we can best present a problem to our algorithms and use machine learning to predict the best way. And that's been proving really, really useful. It's been proving really effective, and we're looking at how we can extend that. So that's something I'm really excited about looking into.